Hey guys, welcome to test number 1. We've completed the first unit together, and I figured an Edpuzzle would be the best way to review and assess you on what we've done. So I'm going to do a question with you, and then you're going to try one on your own. So the first question is adding two trinomials. We want to express our result as a trinomial. Then we're going to point out some things like the leading coefficient, constant, and degree at the end. All right, so the first thing we want to do is find our like terms. So like terms have the same variable, which is x, and the same exponent, something like 2. So 6x squared and 2x squared are going to be like terms. The next set of like terms I see are positive 3x and positive 5x. And the last set would be our constants, negative 7 and negative 3. Now I'm going to add them. The highest exponent should go first. So I have 6x squared plus 2x squared. I add the coefficients, 6 plus 2. I get 8x squared. And the second set, I have positive 3x and 5x. I'm going to add those. 5x plus 3x, we get positive 8x. My next set was negative 7. I'm going to add that to negative 3. Negative 7 plus negative 3 is negative 10. Now that is indeed a trinomial. It's 3 terms, so that is my final answer. Now my leading coefficient, that's going to be the coefficient in front. I know it's the first one because it has the highest exponent, so my leading coefficient is positive 8. My constant, that is the number at the end, which is negative 10. And the degree is the highest exponent. In this case, my degree is 2. Now I'm going to have you try one on your own. So add these together, give me the leading coefficient, constant, and degree, and then we'll go over it. Okay, so here's how you do this one. You find your like terms, 4x squared and x squared with the invisible 1. Negative 9x, positive 3x, and positive 2. Negative 7, add them together, 4x squared plus 1x squared. 4 plus 1, I get 5. X squared. And then I'm going to add negative 9x plus 3x. Negative 9 plus 3, I get negative 6x. Then I have positive 2 plus negative 7. Same thing as 2 minus 7, I get negative 5. That is indeed a trinomial. My leading coefficient was 5. My constant was negative 5. And my degree is, again, 2. Okay, so this is just a regular equation that we're going to solve. I see a number outside of the parentheses. What do I want to do? I want to distribute. Distributing is really what mathematical operation? Multiplication. So I'm going to do 2 times 4x. 2 times 4 is 8. Bring down x. 2 times negative 3, I get negative 6. I'm going to bring down that negative 8 equals 4 plus 2x. Now looking at the left side of my equal sign, I see some like terms. Because they're on the same side of the equal sign, I can just put those together. I bring down 8x and negative 6 plus negative 8. We get negative 14 equals, bring down 4 plus 2x. I want to get my terms with x on the same side. I'm going to start with this positive 2x. The opposite of positive 2x is negative 2x. Whatever you do on one side, do on the other. That cancels. 8x minus 2x, I get 6x minus 14 equals 4. I want to get x by itself. Which number is further from x? It's either going to be 6 or negative 14. Well, it is negative 14. The opposite of negative 14 is positive 14. Cancel that out. And I'm going to bring down 6x equals 18. What's my final step to get x by itself? Well, that's to divide by 6. I get x equals 18 divided by 6, 3. Okay. And I'm going to have you try one on your own. Okay, here's how you do this one. I have negative 8 on the outside of the parentheses. I'm going to distribute negative 8 times 6. Well, that's negative 48. Negative 8 times 5n. Negative 40n. I'm going to bring everything down on the left side of the equal sign. I can start anywhere to get my variable terms together. Well, let's start by adding 40n on both sides. That's going to cancel. 3n plus 40n, well, that's 43n. Bring down negative 5 equals negative 48. The opposite of negative 5 is positive 5. Both sides. All right, those cancel. I bring down 43n equals negative 48 plus 5 is negative 43. My final step, divide by 43 on both sides, cancel that out, and equals negative 43 divided by 43 is just negative 1. Okay. All right, so this one has a tricky set of instructions. They want the largest integer that makes this inequality true. Let's start by just solving for x. Again, I see a number outside of parentheses, so I'm going to distribute. Negative 3 times negative 2 is positive 6. Negative 3 times negative 4x, positive 12x. Bring down our symbol, which is less than. Bring down negative 18 plus 6x. I can start anywhere trying to get x by itself. I'm going to do the opposite of positive 6x, which is minus 6x on both sides. That cancels. I bring down 6. 12x minus 6x. Well, that's just 6x. It's less than negative 18. I want to get x by itself. I have two numbers kind of near x. They look the same, but I have that 6 and that 6. The 6 that's further away is the constant. So minus 6, minus 6. Okay. Bring down 6x is less than negative 18 minus 6, negative 24. And I want to divide by 6 on both sides. I get x is less than, and then negative 24 divided by 6. That gets us negative 4. Okay, now this is not the final answer here. It is correct, but now they want the largest integer that makes this true. So this says basically x values that are less than negative 4. I can use a little number line to help myself out here. I'm going to set one up. There's only 3 numbers I kind of care about. I care about negative 4, which is right in the middle, and then the number before and after. If you recall, negative numbers, they get bigger, so to speak, when you go to the left. And then I have negative 3. I'm going to decide which of these is the largest. So I put a circle. Should that be an open circle or a closed circle? Should be open because there is no line underneath there. So because that's an open circle, it means that -4 is not part of the solution set. So it's either going to be -5 or -3 because it's a less than symbol. I go to the left. So -5 would be the largest number that makes this true. There are other answers that go to the left here, like -6, -7, but -5 would be the largest because numbers just get smaller as you go. So you kind of have two answers here. This one that you got when you solved, and then that one that actually answers the question. Okay, I'm going to have you try one on your own. Okay, here's how you do this one. We're going to distribute 7, so we get 7x minus 35 is less than or equal to 12x minus 40. I can start anywhere to get x by itself. I'm going to subtract 12x from both sides. Okay. That cancels. 7x minus 12x, I get -5x. I'm going to have to flip the inequality later because of that. Bring down -35, less than or equal to -40. I add 35 on both sides. That cancels. I bring down -5x, less than or equal to -40 plus 35 is just -5. Final step, divide both sides by -5. Whenever you divide an inequality by a negative number, you have to flip your inequality symbol, so less than or equal to becomes greater than or equal to, and then -5 divided by -5 is 1. So I have values of x that are greater than or equal to 1. And I want the smallest number that's greater than or equal to 1. So I'm going to set up my number line. I have 1 in the middle, 0 to the left, 2 to the right. I need to put a circle on 1. Okay. This is going to be a closed circle because there's a line that means 1 is part of my solution set and all the numbers to the right. So I really have two possibilities here. I have 1 and 2. They wanted the smallest possible number here. The smallest number there is 1. Technically 1, 2, 3, 4, 5, and so on are answers to this inequality, but because they wanted the smallest, we go with that. And there you go. Okay, let's try another one, multiple choice. So there's a lot of nonsense, so to speak, up here. So I'm just going to cross that out. Okay, I have -3 outside of the parentheses. I'm going to distribute. -3 times x is -3x. -3 times -5, positive 15. And then I'm going to bring down less than 12. Okay, I want to get x by itself. I need to subtract 15 on both sides. Okay, cancel those out. Bring down -3x is less than 12 minus 15. We get -3. What's my final step to get x by itself? That is to divide both sides by -3. What happens when you divide an inequality by a negative? Well, you must flip your symbol. So I bring down x, I bring down greater than, and then -3 divided by -3 is just 1. So that is a solution. However, I look at my choices, and I know 3 looks super tempting as an answer, but remember, this is an inequality. It helps if you write down the inequality. I want numbers that are greater than 1. You can also set up a number line with 1, 2, 3, and then 0, -1. You put your circle on 1. It's going to be open because 1 is not part of the solution. There's no line underneath. And we shade to the right, so I'm looking for numbers like 2, 3, 4, 5, blah, 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 blah. So what is my answer? Well, it's going to be choice 1 because, like we said, 1 is not part of the solution. And then choice 4 would be if you were looking at numbers that are less than. Okay, I'll have you try one on your own. Right, here's how you do this one. We don't need any of that up there. We distribute -4, get -4x. -4 times -1, that's going to be +4, greater than 12 again. I want to do -4, both sides. Cancel that out. I bring down -4x is greater than 12 minus 4, and I get 8. I want to divide both sides by -4. Cancel that out. Bring down x. I divided by a negative number, so I turn my greater than into a less than. And then 8 divided by -4, I get -2. And I'm looking for numbers that are less than -2. Can always draw a number line to help you out. -2, and then to the left you have -3, -4, to the right -1 and 0. Put my circle on -2. It is open because there is no line underneath my inequality symbol, so that means -2 is not an answer. So that, again, gets rid of that choice there. And I'm looking for numbers that are less, so I shade to the left. So what would be my answer? Choice 2, because those numbers are less than -2. All right, let's do another one. I know lots of reading, so I'm going to skip to the part of this question that looks the most exciting, and that would be at the end here. In the function, the number, let's do a different color, 45 would most likely be. Okay, so here's what I want to do. I want to locate the number 45 and ask myself, is it with a variable or is it by itself? It's with a variable. It's with m. So 45m is going to help me out here. It would really help if I knew what m represented. So m is the number of months. So I want my answer to maybe involve months. Also, what operation is in between 45 and m? Well, that would be multiplication. And if you recall with these word problems, multiplication words that we are looking for: per, each, every. So let's look at our choices. I'm looking for a choice that might have per, each, and every. Well, the only one I see is each, and I know I wanted to involve months, so choice 4 would be our best answer. Choice 1 totally doesn't work because a base fee would be a number that is by itself or solo. That would be that one. The number of months of membership for choice 2, well, that's just wrong because the number of months we said was m, not 45. And for 1 month, what? I never mentioned how many months, so that would be choice 4. Okay, try this one on your own. Okay, we kind of covered this one on the last slide, the number 60.55. Well, there it is. That number is by itself. It's solo, which means it has no variable. So it's going to be a one-time thing, a base, something that just happens at the beginning. So if you see a number by itself, good indication that's going to be your base fee. Okay, let's do another one. Let's skip to the end here. They want you to write a system of equations to represent this situation. Okay, so every equation has a symbol, and that is an equal sign. So if they say equations, that means we want more than one. I'm just going to put 2 equal signs on my paper. Now I'm going to look for some totals. I'm looking for some totals there. Okay, here's one. 530, and I notice that that has a $sign. Let's see, do I see any other totals? Oh, I totally do. Total of 20 items. So 20. I notice that 20 does not have a $sign. So now I'm going to start filling my orange equation in, which involved my $sign. So that's a good hint that every number with a $sign should go in that equation. So I look and see that pants are $50, and pants goes with P. So I'm just going to put 50P plus, and I see that shoes, S, are 70, so 70S. There's my first equation. Now my second one, I am actually totally out of numbers. Let's take a look at what 20 is a total of. What's the total number of items? Which 2 items is this equation talking, or is this problem talking about? One is pants, and one is shoes. And how can I represent pants? P. So my second equation must be P plus S. And I know that looks funky, but I didn't have any other numbers, and I was just talking about items. So there is my final answer. Okay, I'm going to have you try one on your own, and then we will discuss. Okay, here's how you do this one. Similarly to the last one, they want a system of equations. Means I want 2 equal signs. Let me look for some totals. Boom. 38.50 was one of my totals. And then I see a 24 bars. Let's work on the orange one. There was your $sign number, so every number with a $sign should go in that equation. Okay, let's see. The 150, that was for almond bars, and they gave me a letter for that, 150A plus, and then 175 for caramel bars, C. My second equation, again, I'm out of numbers, but I know I was talking about almond bars and caramel chocolate bars, so I'm just going to use A plus C, and that would be my final answer. All right, good job on your final question. If you want to redo this, let me know and I will reset it for you. And congrats on finishing your first test. See you in class.